Jai Janendra, Namaste and welcome to my channel. Today we are going to solve the 72nd question of the problem solving series and the 10th question of the topic string. The difficulty level for this question is medium and this question has been asked in Microsoft, Amazon, Google, Oracle and many other companies. Longest substring without repeating characters. So we are given a string S and we need to return the longest substring in which there are no characters which are repeating. Let's look at the example. A, B, C, B, A, B, A, B. Okay, so you can see A, after A, B comes, which is a different character. After B, C comes, which is a different character from A and B. But again, B gets repeated. Okay, so up to here, we can see that A, B, C is the substring which doesn't have any character repeated, and the length of this is 3. Okay, now A, B, C, B, again B comes, A comes. Okay, so in this way the characters can be repeated, cannot be repeated. We need to find a substring which has no characters repeated and the length of the substring should be the max, and we need to return that length. Okay, so here you can see if we consider this A, B, C, then the length is 3. If we consider C, B, A, then also the length is 3. But when we include this B, C, B, A, B, B gets repeated here. So in this example, the length, you can see the maximum length of the substring could be 3. In the second example, you can see B is repeated. So the answer will be 1. There is only one, any substring you can take, its length would be, max length would be 1. Because if we take the second, it gets repeated. Now how do we solve this question? So the first thing is substring, right? Substring, that means we have already solved a lot of questions on substrings. They should be repeated like together, right? The substring is a part of string which has where there is no gap. Okay, the string is together like A, B, and then we can't go to B, A. Okay, it should be together. Should not be any gap between these indexes, right? The indexes are together. Now how do we solve this question? Okay, so if we see this example, A, B, C, B, A, B, say this is the example. Okay, A, B, C, B, B, A, B. Okay, now what do you think? If we traverse this string, okay, and then we store the characters and its indexes. So if we store these indexes, okay, A has come, B has come, C has come, it's there in the map, no character has been written, and then B, we find okay, the B has been repeated. So the maximum length we can store here, it's 3. It has been repeated now. Now what? When the character has been repeated, so you can do one thing that, okay, the character has been repeated, then you have to start it again from, okay, till this length it's 3. If I go further, the characters are repeated, right? So here we can go 3 only. So you can start from again from BC, and again you can continue like that. Okay, so if you do like this, the traversal, you will get the answer, right? You can, because you are storing things, A, B, C, you have stored the indexes. Then when you start from B again, because you can't start from here, right? Or if suppose if you ignore this and start from here, you can do that as well. Okay, but the thing is you need to store the indexes, and if once it is repeated, then you need to again start storing things. That makes okay, let's first look at the naive solution. Okay, so if we start from here, we see the index got repeated in B. Now what could be done next? Since it is repeated, we have the answer as 3. Now we can start, either we can start from B, this side, and see, okay, if we have any substring that has length greater than 3, or we can start from here. Okay, because if we start from here and then we see, okay, still B is repeated, right? So we don't know exactly what we have to do. So in that case, we have to do for all the possible substrings, we can figure out, okay, in this substring element is repeated or not, and that would take a lot more time complexity, right? So if we start from A, all the strings will take here. from B all we will take, from C all we will take, P all we will take, and we will keep on finding. Okay, for this substring, this is there or not. So finding all the substring and then finding the whether it is repeated or not. We have to, if it is not repeated, we store it. So in that way, the time complexity would be order of n cube actually. Okay, it would be too complex. So the time complexity, we need to reduce the time complexity. How do we solve this then? So now you see, if we, for this kinds of problem, we follow a window pattern, right? We have already solved maximum window sliding. I think we have not solved it. It's a similar pattern question, but yeah, this is one of that pattern. So what you can do here in this, what algorithm is, or window sliding. We will slide the window. How do we slide the windows? Here in this algorithm, how do we use this technique? So here you can see, okay, let's look at this example only, and let's look at here. Okay, so this is A, B, C, B, A, B, A, B. Okay, now we see, okay, we store it in map or in set also. Set and map are similar kind of data structures. In set, you can't repeat the elements, right? So if in the set you repeat an element, means like set, right? Set takes only the unique elements. Okay, so the count of the set elements cannot be repeated, right? You can't store the frequency. It only stores the unique elements. Okay, so here you take set and you insert it. A you have inserted, B you have inserted, C you have inserted. And now when you go to B and when you try to insert B, before inserting every time you check whether it is there in set or not. If it is not there, we increase the, like our frequency gets increased, right? But now since B is there, now what you can do, you have a window here, okay? So you are starting from here, this is your left window, and you are going this side, this is your right window. Now when you have reached B and you see, okay, B is already there in the set. So what you can do, B is already there in the set, till here you have a substring which doesn't have a character repeated, right? So you can remove this part, okay, A, from this string to see whether this string, substring is unique or not, right? Because this element could have been repeated here. So if you remove this, then this part can give us a substring which has unique characters, right? So in this way, you will remove this left, you will slide this window left, you will remove this A, and then this L index will come over here. Okay, and now you see that, okay, now this B, is it still present in the set? You see, okay, it's still present. Then you will again remove it. Maybe because of this character, it could be. So you remove this L, you move ahead, and L comes here. Now you remove this B. Now you have only C and B. C is stored in the set. Now this B is not present in the set. Then you can introduce this B, and then you can move ahead. Okay, because this set will only have unique elements. You have removed this element. Okay, so that is the way. So let's complete this. So when we got A is not present in this, you added, okay, and you whenever you go to the next, you find the maximum frequency, right? Maximum number of unique characters. So currently it was A, B, C 3, so you have this 3, okay. Now you have again added A, and there is no unique character, and then you again see B, and B is there. That means the R is here, B is here. B is already there, so you will remove this C, and this L will come in here. Okay, this way you will slide, and you will find the window which gives you the result that you want. Okay, so in this way, the time complexity would be order of n, close to order of n, right? Because logically, if you think, whenever you are traversing, when you reach a point where the things are repeated, so from where can you stop, right? You can't just directly start from the next point, because this side could give you, right? So you would want, okay, if you want to remove this element, whenever you want to remove the element which got actually repeated, you need to remove that element. So to remove that element, the elements which are before it doesn't matter to you. You need to remove that element because that will not make your string as a substring. So for making it substring, you need to remove it. There should not be any gap between the characters, right? So you removed it and then you removed the element which was already there. Now the string that you have is a unique substring without any repeating characters, and then you can continue and find out which string, whether the next character can make your string as a unique string characters without repetition or not by checking it in the set. I think you have understood the logic. Let's code this. Okay, so we take a unordered set of character, it would be, right? And let's name it as set. Okay, string s, and now we will traverse this string. We will have the int answer as 0. Okay, for I, and we'll have answer as 0, L as 0. Okay, and we will traverse for R. Okay, so that's we'll move from the right, so that's why you are naming it as left window, R is right window. For R equal to 0, R less than s dot size, and R plus plus. Also, if so sometimes you forget this conditions, that if the string size is 0, right, that means you need to return 0, right? So if s dot size equal to 0, terminate it that time only, return 0. Okay, fine. Now you are traversing this string. Okay, now what you need to check is if set dot find, if in the set you find that the string R is present in the set. Okay, the next element, that whatever you have got, if it is present in the set, that means it is not in the end. Okay, then what will happen? And if it is not present in the set, that means it's a unique element. So if it is not present in the set, then you just need to insert that element into the set, right? Say if it is, if the character that in the beginning A is not present in the set, right? So it would not come into this condition, and we will insert this into set. Okay, and our answer would be max of the answer that we have previously is 0, and our this would be R minus L plus 1. Okay, you'll understand this, and at the end you will return answer. Okay, so what we have done, we will understand. Let me code it first. So if it is not present, so if it is present in the set, then you insert it in the set and you find this answer like this. How it has come, we'll discuss. Now if it is present in the set, like A, B, C, and then again B has come, so you have to check every time, right, whether the elements are repeating or not. So if the element is repeated, then what do you do then? Okay, so if the element got repeated, that means you need to first okay, if this is repeated, then you need to check while as set dot find, is it till the time it is repeated, you will be increasing this L, right? That is what we have done. So if s dot finds SR while set dot not equal to s dot end, okay, set dot end, I mean not SS string, set dot end. Okay, till the time it is not is in the set dot end, then you need to first remove the element. Set dot what is that library? Set dot remove. I think delete. What was that? Set dot what was the C++ library for that set? Set dot, I think erase. Set dot erase. Set dot erase this s of L. You will remove this first element and then you will increase this L plus plus. Okay, so you will do this. Once you have done this, then it will be increased till the time it is not find. So once it is done, then you will increase this, and our set is this. Okay, yeah. So this has to be done. If the element is present in the set, then we remove this element from the set, and then we increase this L. Okay, and there should be condition that L should be less than R every time, right? Because if it has crossed that string, then it will not happen, right? So while L less than R, and so this is an important condition. L has to be less than R. The left window has to be the lesser than the right window, right? It can't cross this. Okay. So, and this, if it is not found, so once this is done, like suppose we have here A, B, C was there, right? A, B, C. A has been removed. Then when B was removed, then when C is so when B was removed, then okay, while when B is removed, then when we see this set doesn't have B, so this one will terminate because B has been removed. So we will get out of this loop, and then we will insert this B again. Okay. So in this way, we will, and at the end. So once, like, I'll explain this example. Okay. So you'll understand. A, B, C, B, A, B, A, B, right? So we have this set. Okay. So in the beginning, this condition fails. This if L is less than R and this R is not equal to S dot n, it is so it is not there in the set. A is not there in the set, so A comes. B is not there in the set, B comes. Okay. C is not there in the set, C comes. Okay. We insert it like this, and then when B comes, we see okay, B is already there in the set. So and L is less than R. Okay, because R becomes 0, 1, 2, 3 now. Okay, so R is 3, and this is present in the set. It's not at the end. So what we do, we erase this A. Okay, the A we will erase and increment L. L becomes 1. L was 0. Okay, and then again we check. Okay, if this R is there or not. This R character we are in this B. It's still there. So again we will remove this L and increase L. Okay, so L has been removed. So L becomes 2 now. R was actually 3. And now when again we check when B is removed, okay, then we see okay, now it is not there in the set. Okay, B is not there in the set, so we insert this B. Okay, and then when we see what would be the answer. So earlier the answer was, what was our answer? Okay, we didn't store the answer, right? Here, did we store our answer in the beginning? Yes, we stored, right? R minus L plus 1. So every time when we were inserting A, B, C, so L was 0, R was 0, so R's value was 2. So 2 plus 1, 3. So answer was actually 3. Now when we compare here, so our R's value, answer's value is 3, R's value is 3, L value has increased to 2, so 3 minus 2 plus 1 is 2 plus 1, 1 plus 1, 2, okay. So the answer, the value is 2, between 2 and 3 is greater, so our value is 3, so because there are 2 elements in the set. Okay, in this we will compare. I think you've understood the try run as well. The link to the question is given in the description. Please try it yourself and then come to my code walkthrough section. Here is the code walkthrough of the 70-second question, longest substring without repeating characters in the lead code platform. You can see these examples. These are the same examples. Okay, let's look at the code directly. This is same as discussed. We have this answer, max answer. We have the set. We have this left window L, right window R, and then we check this whether the duplicate element is present or not. If the duplicate element is present, we remove it from the set, and then we increase the left window. And if it is not present, if any duplicate element is not present, we insert the right window element to the set, and then we get our current maximum value, and then at the end we return our answer. Okay, so let's submit this. Okay, so it has been accepted.
This is one of the important question, and this question has been repeated in a lot of the companies. It has been asked in a lot of companies. So you need to practice this question. It's a very important pattern based question, sliding window based questions, and this kind of similar questions can be asked in the interviews. Okay, so with this we've covered 10 questions of strings. We'll have 3 more questions, and see you also in the next video where I'll be explaining the 73rd question of the problem solving series and the 11th question of string. Jai Jirendra.